into a little bit more technical perspective on how this interface world looks like. So on AUTOSAR Classic, you have something which is called the atomic software component, and this is like the main part to structure the architecture. And an atomic software component, first of all, it has ports, but the port is pretty much just a hole in the wall, right? So it's a point of interaction. You can throw some stuff through it, but you don't yet know what it is. So you can define a port as some point of interaction, and then the information which is exchanged through this port, this is something you define in an interface. And here you have one interface which has two variables, and again, as I mentioned before, with the single source principle, you define the interface once, and then the sender port and the receiver port are referencing it, and so they will benefit from potential updates on that interface. Now, the term atomic software component sounds like it's not divided into smaller parts, and this is wrong. So for whatever reason, pretty much atomic means that you cannot split the software component and assign parts of it to different ECUs. Okay, so one atomic software component needs to run on one ECU, but actually inside of it you have what's called an internal behavior, and there we come actually to the functions that would probably map to a unit in terms of ISO 26162, and these are called the runnables. So the runnables are independent C functions which are triggered by the operating system, so these are also the functions which we are going to map to the OS tasks, and then these runnables can also communicate. They can access data from the interfaces to talk with the outside world, and last but not least, there's something called an interrunnable variable which allows these runnables to talk to each other being within one software component. And that's about it. That's everything we need to know to understand the AUTOSAR architecture on the application level. And what AUTOSAR doesn't standardize, of course, is unfortunately the granularity of the architecture, right? So the standard is not telling you how big a runnable is supposed to be. So there's a huge degree of freedom. You could have one ECU and it's just one big runnable, and that's probably not a good idea. You could also have 10,000 runnables, and each runnable has just 2 lines of code, which is probably too small and also not efficient. So finding this sweet spot, what's the right size of a unit, what's the right size of a runnable, what's the right size of a software component, because again, do I have one software component with 3 runnables, or do I have 3 software components with 1 runnable each? You decide, right? So in the end, the question is what makes sense from your project perspective when it comes to testability, when it comes to reuse and these kind of things. But this is of course something which also sometimes leads to AUTOSAR architectures which are compliant to the standard, but not really efficient and not easy to maintain. So that's definitely an observation here.